Welcome back to question 3, November 2021, grade 11. It was an analytical geometry question rather. Let's look at this one. I am Gaston Mapala. Let's go through this question together right here and see what can we learn from this past paper. All right, A, coordinates are given there, B and C, and then D are vertices of a trapezium. Right now, when we are reading this question, we should be able to know the properties of a trapezium so that we are able to work with this. And then they are saying to us AD is parallel to BC. All right, E is a midpoint of it's a midpoint of what? Here's the E, here's E there. I already see E here. Said E is the midpoint of BC. Where is BC? Okay, BC. All right, okay. I think this coordinates moved a little bit, but it's fine. BC, E is the midpoint, is okay. The angle of inclination of the line BC, there is theta, and as shown in the diagram below. All right, great stuff. So now let's set question number 1, 3.1. It says that calculate the coordinates of E. Okay, 3.1. I want us to calculate the coordinates of E. They already told us that E is the midpoint, so therefore we are going to use the midpoint formula here, divided by 2. Some of my learners, they rather prefer that here we use letters, but it really doesn't matter. You can use letters here. Instead of saying y1 or y2, you can say x, y at B, and then y at C. Doesn't matter, the answer will be the same. All right, as long as you choose your coordinates correctly. Let's say this is coordinate number 1, this is coordinate number 2, like we did previously on the past paper of 2022. Right, so x1 will be 3, and therefore plus x2 will be 12 all over 2. And then let's come this side. Y1 is 0 plus y2, which is 3, divided by 2. Therefore, when you come here, so therefore the coordinates of E, which is the midpoint of BC, will therefore be given by, here is going to be 15 all over 2, and then this side is going to be 3 over 2. All right, so we got those coordinates here. We are going to put them here on the diagram just to make sure that if we want to use them after that. All right, and then they said 3.2, they are saying that, okay, determine the gradient of line BC. All right, gradient BC, gradient is going to be given by, now I'm going to use letters here on this formula so that you guys are able to follow, the y at B minus the y at C all over the x at C at B rather, minus the x at C. Excuse me, there you go. So we are gonna come here and say, okay, what are the coordinates at B? Coordinates at Y, the y at B is 0 minus the y at C, which is 3 all over the y. The x at B is 3, and then minus 12. All right, therefore this gives us a gradient of minus 3 all over minus 9, which all in all is going to give us 1 over 3. Okay, here we go. Great stuff. So now let's move on to 3.3. 3.3 said determine the value of theta. When we read at the question here, they said the angle of inclination of line BC. So we know that theta, we know that angle of inclination somehow is related to tan is the angle of theta. Wait a minute. It's not like that, but it is like that. Tan theta is equals to the gradient, okay, which in this case is going to be the gradient of BC, because we are looking for theta, which is the angle of inclination that the line BC forms with the x-axis. All right, remember, angle of inclination is the angle that the line forms with the x-axis. So we are going to come here and say, so therefore theta is going to be equals to tan, second function on our calculator, 1 over 3, which is going to give us the angle of inclination of, in this case we are getting 18.43. Right, guys, please, very crucial, don't forget the basics. If you forget the basics, please go back and watch our video on the lesson of analytical geometry grade 11. I'll try to put that one that lesson on the description below of this video. So let's move on to 3.4. 3.4, we are required to prove that AD is perpendicular to AB. So therefore, let's have a look at this one here. On the question, it says AD. So therefore, the gradient of AD is equal to the gradient of BC, which is equals to 1/3. Okay, so now we must go ahead and find the gradient of AB. So gradient of AB, coordinates of A are given by 1, 6, and then the coordinates of B are given by 3:0. Therefore, using the same formula here, we can substitute and look for the gradient of AB, not AD rather. All right, so here we go. AD is going to be equals to y1, which is 6 minus 0, and then yx1, 1 minus 3, which gives us 6 over negative 2, which is 6 over negative 2, which gives us negative 3. Okay, and then therefore, with that said, therefore you check, they said we must prove that gradient of AD is perpendicular to the gradient of AB. Okay, which is must give us negative 1. Let's have a look. AD is what? AD is 1/3 times the gradient of AB, which is minus 3. Therefore, the answer here gives us negative 1, which therefore means that AD is definitely perpendicular to AB. All right, great stuff. Now let's move on to 3.5. Okay, we come here. 3.5 says here, a straight line passing through vertex A does not pass through any of the sides of the trapezium. This line makes a 40-degree with the line of AD. So you've got a line here passing through this one and doesn't pass through any other point, and then it makes a 40-degree angle with AD. Okay, it's fine. So maybe this line is passing somewhere here, it's making a 40-degree angle there. Okay, if you understand the question correctly, and then determine the equation of this straight line. Okay, all right, they said determine the equation of this straight line. Okay, so now if we have a look, we did manage to calculate this theta here. So now the angle that this straight line forms, because it's passing through that line, it's forming that line. So it means now we have got the line, we have got the angle of inclination, or line is forming angle of inclination. Okay, you guys will know that the line angle of inclination is somehow related to the gradient. All right. Okay, I think we discussed that area when we're discussing the question, the previous question before this one. Please, if you don't understand, go and watch that one, or watch a lesson on analytical geometry for grade 11. All right, so therefore this means the total, this makes the total angle of inclination to be equal to 45 plus this one that we calculated here on 3.3, which was 18.43. So therefore the total angle will therefore be 63.43. all right, so the relationship between the angle of inclination and the gradient is given by gradient of a line is equals to tan what angle of inclination. All right, is given by this So therefore, if we have got the angle of inclination, we can come here to find this gradient for this line at point A, which is 63.43 close bracket, which gives us 2. So therefore the gradient is 2, and then they said the line is passing through point A and no any other point. All right, so point A is given by the coordinates 1:6. All right, so we know our equation for the straight line y is equals to y at A is equals to the gradient x minus x at A. There you go. Therefore we can substitute here. We are going to substitute y, which is -6, is equals to the gradient of 2x, and then therefore we are going to have -1 here. And then if we do everything here, find the y on its own, -2 plus 6. Therefore our equation is going to be equals to 2x plus 4. Okay, and that's how you would deal with a question like this one. The relationship between the angle of inclination and the gradient has taken place here. And if you still don't understand, please stay tuned for this channel, because we are going to be doing question 3 of November 2020 up next. See you on the next upload.